Okay, my friends, another shocker today. Mudfossil University. I believe I have discovered another new anatomical process, let's call it that. And what it refers to as the hair root. Now, this is right here the same as that right there, this follicle. All right, the hair follicle. Out of that grows the hair. There's sebaceous glands. There's actually muscles attached to every hair. That's why your hairs can stand up on end. And I can show them every bit of that in this particular sample. Plus, I can show the root actually turning and wrapping around and coming up, which is, I don't think, understood. All right, let's just start with the skin. This is the skin. They're showing nice and smooth. Not that way at all. This is where the hair comes right up through the skin, is right there, all right, in the microscope. All right, here it is, right here. Now, what are we seeing? This is all skin. That's all. And I'm going to show it to you in an actual microscopic shot of actual skin growing. Now, check this out. This is just drives me crazy every day. Look at these little pockets back here and all this little scruffy stuff around the hair shooting up through here. Look at this. This is my giant follicle right here. It's identical. There's those little pockets in there and all that little coming around. I mean, it is a hair follicle, so we got to get off the dime here and start paying attention to reality. Because there's so much to learn here that it's just, and I'm sure, I know the kids are having a blast seeing this stuff, but they're being told not to pay attention to it because it goes against what they're being told to repeat, literally. I mean, that's what it is right now. It's repeat what I say and you'll get a good grade. If you don't, then I will fail you and tell everybody you're stupid. All right, this is outrageous. I'm just going to show you right here this hairball follicle. That's where the hair actually emits through the skin up here. This is actually the sebaceous gland. You see this? This little wrappy thing here, you see it? That's the sebaceous gland. Then the hair comes down. This is how hairs develop. I don't know if they know this. This is the hair coming up. They're showing as like one just root. They're saying this is the root, and it just starts and grows. It wraps around in a circle. You see that? I don't think they understand that. That grows from there around this circle up and then emits through the top. So it really is growing around in a circle and then coming up. It's not just coming straight up. All right, now this is the muscle. This is what they call an erector pill muscle. You see this? It attaches right there. That's it right there. And it goes up to your skin and it makes your hair stand up on end. Now, this is a hair follicle. This is pretty good size compared to the ones that are in you. Now here's that hair follicle. It's in the microscope right there when we're looking down. It's a telescoping microscope. Works very well for this kind of work. And you can buy them cheap. That one there is, I think, was kind of expensive, but that was a long time ago. And, you know, it's a name brand and so forth. Anyway, this is what we're looking at here in the microscope. That's the bottom. Okay, so here we go at the top. There's our hair. All right, come down the side. All the way down here is where the hair starts from. So, let me get my little pointer. This right here is the hair coming forward. And it continues up, and comes up the top through the skin. Alright, I hope you can see all that. Now, so this is starting. This guy looked like a guy had white hair. I don't know. Now, where does it start from? It starts from down the bottom, down here. That whole ball sort of wraps around in a circle coming up. Now over in here, this is hard to do. I have to use supplemental lighting on this to see it correctly, but somewhere over in here is where the blood, because there's a blood supply in here too, And I think it might be right up in this area here. All right, this is the very bottom. And I believe that's where the blood is entering, from the very bottom. There's going to be a red and a black. So, well, when I say a red and a black, I mean a vein and an artery. And I think they're right there, right side by side. See them? All right, yeah, I believe that's it right there. Hold on, hold on. That's definitely one of them. And I think that's the other. That's what I'd say. That's my guess. Now, let's look at the muscle. All right, so we've got the hair coming up the top. Right there is where that pill erector muscle, erector pill muscle, is attached. And that makes you stand up on end. It could be laying down like this and pops it right up on end. All right, so that's where the muscle attached right there. Very, very obvious. All right, and it's exactly in the right place. Now, over here, on the other side was that, hold on, see if I can find it. Right there. You see this? Let me see if I can focus it. You see that? That's the sebaceous gland. That's the oily stuff that squirts in for your hair. And this is what I think is a new discovery, is the fact that the hair actually wraps around from the bottom and comes up. Now, the reason I can say that is because that ball is not part of this hair. This hair is wrapping around that ball coming up. And it has started from way back here at the very, very bottom. All right, it's growing like fibers out of here. Again, let me see if I can home in on that. Oh, it's not too bad, but you see, it's growing like fibers into this, which wraps right around whatever this is. And then it comes up through the follicle, up through the top. And at the same time, the erector muscle is here and can push this up and out. So that's a giant hair follicle, and that's pretty damn big compared to what's in your body. Okay, my friends, I would say it's time to do a little bragging, and as my old boss used to say, if it's true, it ain't bragging, and this is true. I just showed you about the hair follicle. When I first discovered mud fossils, I realized that everything was being preserved because of the fascia layer, which is made of collagens and fibers. And in certain areas, it's extremely dense around your lung because it has to do this all day long. It's like a rubber bag going up and down. Now, around your bones, it's the same stuff, but it's in a different configuration. In feathers, in my goose Caesar, it's the same collagen. And even the patterns in his head are here because they all died in a hot saltwater flood. And they're all flat on one side, flat, 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 and on the other side they are perfectly, flawlessly preserved. And I understand now, from working with this for over 10 years, the process that invades the collagens and creates feldspars. These are all feldspars. That's a bone. That's a regular bone. There's no bone to it because the calcium did not last in these kind of environments, in these salty waters. That's what they look for, is bones, but there's no bones. The bones are encapsulated inside the fascia. There's bones in here, but now they've turned to basalt or whatever the invading nucleophilic invader was. There's entering groups and leaving groups in aqueous chemistry, in salty waters and acids and stuff. So they want to flow in, some want to attach, some want to leave. The attachers come in and say, I will bond with you and we will become stable if you can get all this nasty stuff out of here, which a nice clean water washes it out. Bloop, they lay there and they dried out. Now they were like parboiled in in a hot saltwater flood that happened because we were almost impacted by Venus. If you don't read Velikovsky, you are not educated. So what am I bragging about? Well, I'm bragging about possibly discovering a new formation of hair. Now, the other thing I'm bragging about is discovering the interstitial layer, which they never saw before. 2018, there's an article out that says, meet your new organ, which is this interstitium. Well, not only that, the interstitium is all the balls that you see all over the earth, these gigantic balls. I'm going to show them to you in a second, because nothing that we have been told is correct as far as our history, as far as this geology, as far really basically everything. Now, in addition to that, I discovered that this exact layer right here, that one little strip, is the fluid-filled highway called the interstitial fluid, that is where the bacteria lives, and that sends all the enzymes back and forth. And that's in that one tiny little layer. And I've proven that by the catalase reactions of enzymes, which are I'm calling this the immunothelium. You know, you have your epithelium, epidermis, and so forth. This is the immunothelium. In that layer is your immune system. Everything out here can come in up to this far. Don't you try to get down in here in the blood and all that business. You can stay up in there in the gooey stuff. You get down here, we're going to kill you. And that's what happens. That's your immunothelium. So I've shown some pretty good evidence of what I think is, well, I know what I got, because this is DNA tested human. My giants, and I have giants, and there are giants everywhere, and my giants aren't even giant. My giants are just little puppies compared to what's out there. There's meat everywhere. Oh, and I discovered the spurlock, too. I named it the spurlock. That little attachment there. Hold on, let me show you that. Okay, this may or may not be understood, but I'm going to call this the spurlock. And this is what it is. It anchors organs and body parts to other tissue through straps and so forth, because everything has to anchor together. This is the fabric of the membranes, which is interstitial. It's the fascia, and that is the little latch, the same as this latch. And they're on everything. I mean, I have them all over. Virtually every organ that I have has that specific latch in it. That's how your body stays together. All right, remember I told you I actually discovered this. Nobody saw this before, because when they take slides of this, they flatten them out and they shine light through them to see these kind of things. I come down, like I showed you with my microscope, which is telescoping. Anyway, I found these balls, and all this fascia was the protecting coating that was making my mud fossil. So I get a hold of Gil, and we go through this, because he was the one, he had something called fuzz. What's the fuzz or something like that, which is this stuff here. And they used to just pull it out of there, and they didn't think it had any value at all other than a cushioning value. Well, that changed. But let me tell you else, what really changed is this. That is interstitial. That's an eroded body of some creature that is hundreds of miles long. I'm sorry, this is what happened on this Earth, and it is also on Mars, identical. These are the Mars blueberries and the Mars Morse code. I'll show you in a second. And I can also prove that it is from Mars, not from Earth, because of the way it eroded. You see this here? This is the interstitium. All right, these are the balls that were attachments here. You see the balls? Here, let me come back down here. This is the red gooey stuff here, right here. That's all floppy and pulley and all that stuff. That's what makes you be able to gush around and come back to where you were in the beginning. Those balls and these straps and around these fluid-filled bags allowed all that movement. The balls have eroded out from this wall of flesh, and the wall of flesh now has become mud. All right, this is important for you to understand the details here. People don't pay attention to the details. Oh, look at that, and have a nice day. No, I go for the details. These are solid. I know what they're made out of too. This is mud. I know what that's made out of too. It's made out of fleshy red, bloody ferrous oxides and metals and so forth. Now, this is the wall that has all these balls. That's where they came from. This is mucosa, interstitium, and the balls. Now, check this out. All right, and like I say, I believe that I am the one that discovered the immunothelium, which is this layer right here between the membrane and the interstitium, which says if you can get past me, you could cause some hell of a problem down in this tissue. So I am going to react violently when you come through this layer, and it just foams right in this layer. And I've shown this, it's the catalase layer and the enzyme layer. And that enzyme layer is the only way you get enzymes naturally is from bacteria. They live in your body in those fluid-filled bags that I showed you. They're living all down in here, the bacteria. And they squirt up into their enzymes. And those enzymes are extremely reactive catalysts. That means they break things down just so fast. It's absolutely stunning how fast they work. Hundreds of thousands of times in 1 second they interact with other molecules. It's just phenomenal to watch. And that's this layer right here. If you don't have the bacteria living in here, because you took antibiotics, which antibacteria, you killed them, they can't squirt the enzymes out there. No enzymes, the guy comes through, you're sick. Pre-existing condition. So don't forget, I don't think they just come popping straight out of the center of the hair root. It's wrapping right around in a circle. You can obviously see it. It's growing right out of here, coming wrapping around and coming right up through the top. Now, and also we can see the sebaceous glands. There they are right there, you see them? That's the sebaceous glands. And right there, that's the erector muscle, the pill erector muscle that pulls the hair back. What a world. Alright, so here's the hair follicle. It's exactly 2 inches wide at the base. Some mathematical wizard might want to do that conversion, but I don't know, 500 times bigger than the hair, 1,000, I have no idea. But it's, you know, it's consider your head filled with these. Every hair on your head had one of those inside. How big your head would have to be. All right, so everybody knows I do a lot with health issues too, and I relate everything, literally everything, to the enzymes that are created by the bacteria that are in your body. Some of them are good, some of them are bad. You have both of them in your body right at this instant. You cannot live without the bad, and you cannot live without the good. Simple as that. Now, you have to keep the bad under control. You have to keep the good strong enough to resist. So I've been talking about this root, and I know. Have you ever had ingrown hair where it gets sore and everything, and you pull the hair out and it's black on the end? Instead of turning around and coming up, it's going down. It appears. They call it ingrown hair. Well, now I can see why. It's not just starting from there and growing up. It's wrapping down around and coming back up. So somehow it didn't catch the wrap. That's all I could think of. You had to pull the follicle completely out. That's the only way I know of. Now, listen to this. Alopecia areata is an autoimmune disease. What does that mean? You do not have the catalase and the enzymes in your immunothelium, which I told you that I discovered, so you cannot fight back from the bacteria that is attacking you. Now listen to this. This is unbelievably clear. This is an autoimmune disease. The immune system mistakes the hair follicle for foreign cells and attacks them. Well, that's what they think. What happens is there is no way to attack, so they start to throw everything they can at it, and that's called a cytokine storm. It often causes hair to fall out in clumps. That's because that whole region's bacteria is missing, it's dead. Something has attacked it. That's what they got to start looking at, is what bacterias are still viable in these diseased tissues. It can lead to alopecia universalis, which is a total loss of hair all over the body. What that means is you don't have that bacteria in any of these follicles. Your bacteria is gone. You don't have the bacteria, you don't have the enzymes. You don't have the enzymes, you are going to be sick. That's just a fact. All right, I talked about good bacteria and bad bacteria. This specific bacteria that is here, specific to this sebaceous glands and erector muscle and this specific type of tissue, specific. On the lungs it's different, on the heart it's different, on the kidney it's different. Every single one of them works with different types of chemistry. So the bacteria that reside there have to be resident and being able to work with that chemistry that's in a local area. You kill this particular type of bacteria, that one strain of bacteria, and your whole entire body can be destroyed because the bacteria is not there to help you. So either you have to put that bacteria, you have to put the bacteria back in there somehow to get better. Whether you just support it with the enzymes that the bacteria create, because bacteria are the factories. Remember this, bacteria, single cell, roaming all through your body in this interstitial layer. Factories that create these specific chemistries called enzymes. If you don't have them, you can be attacked and killed. Enzymes are a two-edged sword. They're exactly identical to viruses. Viruses either kill you or protect you. If they protect you, we call them probacteria. If they kill you, we call them a pathogen, an antibacteria. Simple as that. They both do the same thing, chemistry, advanced chemistry. We need to get the bacteria in the certain regions under control. Same with like breast cancer. They say you should have a double mastectomy for a while, they were saying, because if one of them's bad, the other one's going to go bad. Well, that's because it's specific chemistry to the mammary glands. It's a chemistry. There's no bacteria on one side, it's not going to be on any other. It's simple as that. Okay, I'm going to leave it at this. This is what a hair follicle is. This is what I was showing you. These are the hair follicles. It surrounds the root and strand of the hair. The root. They think it surrounds the root and just comes straight up. It doesn't. It goes around and wraps up. Hair follicle exists in the top 2 layers of your skin. So this is, in the layer of the skin, that's about it. You're born with over 5 million hair follicles in your body and over 1 million in your head, on your head. As you age, hair grows out of your hair follicles. Now, this was just in July of 2022, and I've been reporting about this hair follicle structure a little bit. Maybe they're taking notice, and maybe they want to change the way they state this happening. But I showed every bit of the anatomy, and it's not hard to understand. And you can actually see the proteins linking together and starting to create the hair at the bottom. It's just stunning, the detail in the mud fossils. And if it doesn't get taken seriously, this is just crazy to walk around talking about all these things. We wonder with this, we wonder that. Well, you have to take a look at things to stop. You have to be curious. I see no curiosity in science whatsoever. It's a complete wall of silence when I come with my evidence. And I have evidence. I don't come empty-handed ever. All right, so it's time to change the way we do business in education. And today is the perfect day to do it because it's falling apart anyway. You might as well straighten it out right now, one time, right from the beginning. And no more of this core curriculum, you have to say exactly what you're told to say. No, you learn in an environment like this. All right, this is the way to learn. It's like at a convention. We go around and you look at these different things, electronics and, programming and whatever. And then you have to have a machine shop attached, a garage, cooking, how to cook, cleaning, how to sterilization works, and everything. This is real life stuff you should be learning, not just say, this is igneous rock. This is metamorphic. It took 10 billion years to grow. There was a big bang of nothing turned into everything. And now it's all moving away at us faster than the speed of light, which cannot happen. Not a single word is working. So if you don't start over, you're just walking in circles. See, and here's the other thing. This is not 150 million years worth of sedimentation. Not by a long shot. This is actually muscle and connective tissue and membranes. That's how dense the connective tissue and membranes are in your body. Very few people have any knowledge about this. I started into these membranes, and again, because it's all fascia. This is fascia, basically down to about here. Then you start to get into your, your muscles and connective tissue, whatever. But up in this area, it's all fascia. It's the coating. It's the coating of these bones. It's the coating of this lung. And even it's on your skin is fascia, basically. On the goose is fascia too, but it's a form of feathers. It's the protective layer that keeps you away from invasion. It's the immunothelium. And it's on everything. And every single organ has it. And every single part of your body, inside your intestines. That's the membranes that separate one type of tissue from another and separate you from the rest of the world. I don't care if it's inside you or outside of you. Membranes are a separation layer, and they are dense as hell. Trust me, I work with Gil Hadley, who was one of the top anatomists in the fascia field. He was the one that started with me 10 years ago or so, because he was the only one who listened to me. He's the only one who really knew anything about it at that time, other than there was one other guy. He runs, I think, the Institute in Germany for fascia research. And they were rolfing. Mostly this is all about, this fascia is about the connective tissue that coats your body is really your muscle system. It works in conjunction with all your muscles. Let me show you the Spurlock. That'll explain it a little better. But everything is connected together. And through these highways, these fluid-filled highways, zip, 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 go these bacteria. A bacteria has a flagella on it, which is like a flagella, which is like a propeller. And they go 100,000 RPMs. You imagine how fast that thing's going through your body? That's why you take something, eat something, a couple seconds later you feel better.